Our Calculus BC course will start with some review of things that you might have even learned back in Algebra 1, but it's always good to have a quick refresher and maybe learn how they're going to incorporate these things into our calculus studies. We have got just a simple section here on slope, equations of lines, and systems of equations. And I've broken the notes down into 3 different objectives. Students will learn language for slope and calculus as average rate of change, and that's something that call it AROC. Whenever you see AROC, just remember, hey, that was the first thing you taught us. That's right, and I taught you that AROC equals slope. Our second objective is going to be that students will practice writing equations of lines and learn the language for writing the equation of a tangent line. And once again, that's what calculus likes to refer to them as tangent lines. It's no different than writing the equation of a line. And our third objective for today, students will review solving a system of equations. So slope, what is slope? It's what it was back in Algebra 1 when you learned it the first time. It's rise over run, or the change in y over the change in x, or if you have 2 ordered pairs, y2 minus y1 over x2 minus x1. My little y's up trick. Remember, the y's go up. Get it? Y's up. Haha. Okay, you don't have to laugh. In calculus, we will often refer to slope as the average rate of change. AROC equals slope. You might be wondering why I'm writing this twice now. This comes up so much in the class, and every time it comes up, you're going to think, oh, how do I find the average rate of change? And I'll say, it's just back to that old slope formula from Algebra 1. A form that we will use a lot in calculus is this point slope form. Y minus y1 equals m times the quantity x minus x1. In calculus, you will be asked to write the equation of a tangent line to a relation. This form is the most common form in writing such equations. You don't need to take this point slope form and change it into slope intercept form unless a question specifically asks you to, or if there's some advantage to you doing it. This is the slope intercept form, y equals mx plus b, where you solve it for y. But again, if it asks for the equation of a line, we stop right here in calculus and say we're done. There's also the general linear form, which I've never seen come up in a class, but just thought I'd throw it out there just to review some words with you guys. Vertical lines. Vertical lines obviously go vertical, they're up and down, and they have an equation x equals some real number. Horizontal lines, those are our back and forth lines, and they have the equation y equals b, where b is always the y-intercept and also any real number. Horizontal lines have a slope of 0, while vertical lines have an undefined slope. Now that is something you're going to want to keep track of in this class, because where slopes are undefined and where slopes are 0 tell us a lot about a function. Last thing to just know about and remember, parallel lines have the same slope, while perpendicular lines have opposite reciprocal slopes, which are referred to from time to time as orthogonal in calculus, meaning they intersect at right angles. So here's a lot of language for you, from something that you were familiar with to how you're going to need to refer to it throughout the course.